In this video, we will explore UAV sensor functionality testing, essential for safety and optimal performance.
Why is it important?
UAV sensors, such as the gyroscope, accelerometer, magnetometer, and other navigation sensors, play a crucial role in flight stability, orientation, and accuracy. Problems like electromagnetic interference, dust accumulation, or mechanical shocks can lead to inaccurate data and deviations. Testing the UAV sensor is essential to ensure a safe and precise flight. Each sensor must be checked to confirm it provides accurate data and is free of errors. The tools and software needed for testing are physical tools, multimeter to check voltages, sensors, oscilloscope for analog signals, PC laptop for software analysis, compressed air for barometric sensor testing, testing software, Betaflight, iNav, 4 FPV drones, Mission Planner, Q ground control for UAVs with Artiplot, testing each type of sensor, testing. Problems that may arise: drift, excessive vibrations causing the UAV to tilt uncontrollably. We connect the UAV to the configuration software, navigating to the sensor's calibration section, checking the gyroscope and accelerometer data. The UAV on the table should show 0.0.0 for the accelerometer and no drift the gyroscope.
We test the sensor's response.
Tilting the UAV to 30 degrees, the software should reflect the correct change. We rotate the UAV and the gyroscope should indicate the movement.
If there are errors, we perform IMU recalibration.
Testing the magnetometer. The role of the magnetometer is to indicate direction and orientation.
Problems that may arise:
the UAV doesn't hold direction, magnetic interference, incorrect readings.
Testing procedure.
We connect the UAV to the configuration software and open the Compass tab.
We check the UAV's direction on the map. It should point to the correct north.
We perform calibration by rotating the UAV in all directions. We save the settings and check if the position stabilizes.
We test on the ground.
We move the UAV to a location without electromagnetic interference and check if the direction remains constant.
Testing the barometer. The barometer's role is to measure altitude. Problems that may arise:
the UAV ascends or descends on its own or has large altitude errors.
Testing procedure.
We connect the UAV to the software and read the ground altitude value.
We simulate an altitude change.
We apply air pressure using a compressed air spray near the sensor.
If the altitude changes in the software, the sensor works.
If the altitude value remains constant regardless of the test, we replace the barometer.
Testing the GPS module.
The GPS module's role is positioning and navigation. Problems that may arise include loss of signal, large position errors.
Testing procedure.
We ensure the UAV is outdoors, far from buildings and trees. We connect the UAV to the software and check the number of satellites detected, which should be between 6 and 8 for a stable GPS fix.
We check the positioning on the map.
If the UAV shows an incorrect location or fluctuates, the GPS may have problems.
We perform a flight test. Testing optical sensors.
The role of optical sensors is to detect obstacles and analyze visually. Problems that may arise include the UAV does not correctly detect the terrain.
The image quality is poor. Testing procedure.
Image test. We activate the sensor and check the image in the UAV software.
If there are spots or scratches, we clean the lens. Obstacle detection test.
We place an object in front of the UAV at the minimum detection distance, 1 meter for LiDAR.
If the UAV does not react, the sensor may be defective. We check the sensor logs for software errors. Testing obstacle avoidance sensors. The role of obstacle avoidance sensors is to prevent collisions. Problems that may arise include the UAV does not detect obstacles or there are false alarms. Testing procedure.
Manual test. We activate the UAV and move a large object near the sensor.
The UAV should display the correct distance in the software. Flight test. The UAV flies close to a wall. It should brake automatically. If the sensor does not react, we check the connections and power.
Final test. Test flight. After checking each sensor, it is important to perform a real flight test to confirm that all systems are functioning correctly. Final test. We take off at low altitude and observe the UAV stability.
We check the response to slow and fast movements.
We activate GPS and obstacle avoidance functions and observe the UAV's direction.
We monitor the telemetry and note any abnormal values.
Conclusions and recommendations. Test the sensor before every flight for maximum safety.
If a sensor does not work correctly, calibrate it before replacing it. Check connections and cables, as many problems arise from loose connectors. Use live monitoring software to detect problems in real time.